Welcome. This video will guide you through querying data in Snowflake using Python. Snowflake, a leading cloud data warehouse, offers robust Python integrations for seamless data querying, processing, and analytics. We'll explore how Python can be used to interact with Snowflake, leveraging its scalability and performance for efficient data analysis. By the end of this video, you'll understand the key concepts and be ready to start querying your own Snowflake data with Python. The first step in querying Snowflake with Python is establishing a connection. We'll use the Snowflake.connector module. You'll need your Snowflake account URL, user credentials like username and password, or ideally key pair authentication or OAuth for secure access. Remember to handle your credentials securely to protect your data. Here's an example of establishing the connection. Replace the placeholders with your actual Snowflake credentials. Once connected to Snowflake, you can execute SQL queries using a cursor object. The cursor allows you to run database commands within your Python session. You can execute SQL queries directly using the cursor's execute method. This sends the query to the database for processing. For better security, use parameterized queries. These use placeholders like %s and pass values separately. This prevents SQL injection attacks where malicious input could harm your database. After executing the query, use fetchAll to retrieve all the results. This returns the data as a list of tuples, which you can then process in your Python code. Snowpark for Python is a powerful feature that allows you to write Python functions that run directly within Snowflake's compute engine. This approach minimizes the need to move data out of Snowflake, reducing latency and improving overall performance. The key benefits include significantly reduced data movement and enhanced performance, making complex data operations more efficient. Snowpark's key components are sessions, which handle connections to your Snowflake environment, and DataFrames, which provide a familiar Pandas-like interface for data manipulation. Overall, Snowpark is essential for achieving scalable and efficient data processing directly within the Snowflake platform. Snowpark DataFrames resemble Pandas DataFrames in structure and operations, allowing familiar data manipulation techniques. However, they run directly on Snowflake's powerful compute infrastructure, keeping data processing within the cloud environment. For comparison, a Pandas DataFrame organizes data in rows and columns locally. Snowpark DataFrames provide similar functionality, but with the scalability of Snowflake's distributed computing. Snowpark enables processing large data sets directly in Snowflake without moving data, as shown in this data landscape visualization. Here's how to use Snowpark DataFrames. First, import the session class from snowflake.snowpark. Next, create a session using connection parameters. Then, create a data frame from a Snowflake table. Finally, filter the data frame based on a condition, all executed within Snowflake. The filtered data frame contains only rows meeting the specified condition, processed efficiently on Snowflake's infrastructure. Python's rich ecosystem offers numerous libraries for working with Snowflake data. The Pandas library can read query results directly into a data frame using pd.readsql. SQL Alchemy provides an ORM-like interface for querying Snowflake data, allowing Pythonic database interactions. For advanced analytics, integrate libraries like scikit-learn or TensorFlow within Snowpark UDFs to perform machine learning directly on Snowflake data. To optimize your Python querying in Snowflake, start by using virtual warehouses for compute isolation. These separate computing environments prevent resource conflicts and allow you to scale compute power independently from storage. Next, manage transactions carefully by setting con.autocommit to false. This gives you better control over when changes are committed, allowing for rollbacks and ensuring data consistency in complex operations. Leverage result caching to speed up repetitive queries. Snowflake automatically caches results for a period, reducing compute costs and query times for frequently accessed data. Prioritize security by implementing role-based access control. RBAC assigns permissions through roles, ensuring users only access what they need for their tasks. Finally, ensure data encryption at rest and in transit. This protects sensitive information both when stored and during transfer, maintaining compliance with security standards. Trends in Python querying with Snowflake are evolving rapidly. The trend is moving towards serverless Python functions triggered by data changes in Snowflake. This enables real-time processing without manual intervention. Deeper AI-driven querying is on the horizon, with enhanced integrations allowing natural language to SQL conversions and model inference directly in Python. Integrations with tools like Databricks are expanding, creating seamless workflows between different platforms. Experts predict Python will become even more central to Snowflake Analytics in the coming years, enabling faster and more intelligent data operations. Keep an eye on Snowpark enhancements and AI integrations for the latest advancements. This concludes our video. Thanks for watching.